and I are just a small speck of dust in the universe, but carry the sparkling beauty of the stars here. Perhaps the most interesting thing about the universe, every time we look up at the night sky, seeing those distant glimmering lights, we cannot help but admire that they have shaped religious culture and the advancement of science even on a clear night. When you find a place far away from city lights, you can only immerse yourself in the night sky with about 3,000 stars. Most of them are lonely. We have learned about the greatest celestial bodies before the energy that makes these stars comes from the interactions between atoms. So to understand the largest celestial bodies in the universe, we have to start with the basic atoms. When a star's life ends, those basic principles will come into play again to predict what will happen to it in the early universe. When no stars were formed, only two elements existed, hydrogen and helium. After the first stars were born, they began to convert hydrogen into helium through nuclear fusion, the same process that the Sun, 000154, is doing today. When these stars die and leave the main sequence, they begin to use helium to create heavier elements like carbon, nitrogen, oxygen, silicon, iron. Giant stars, when they are nearing the end of their lives, will explode and become bright supernovas that release these heavy elements into space, some of which will be captured by the stars, newly formed, absorb this process, just like humans are born. Go away and die. Stars are formed from giant, magnificent, molecular clouds with fog-like shapes. How can such loose molecular clouds become dense enough? Stars to fuse hydrogen into helium. Gravity plays a big role in this. British astronomer James Hopwood Jeans calculated the largest mass a molecular cloud can reach before it starts to collapse, due to gravity. Astronomers call this the Jeans mass, and it depends on the temperature and density of the cloud. Molecular cloud collapse is often triggered by external events, such as the merger of two molecular clouds, increasing their mass beyond the Jeans mass, or a shock wave from the explosion of a nearby star hitting the cloud, causing it to shrink further and continue to collapse under the influence of gravity. As it collapses, the molecular cloud breaks up into smaller parts. These regions, called protostars, begin to spin at an increasingly faster rate, like an ice skater pulling his arms in as he spins. The temperature and pressure in this region increase until this rapidly rotating ball of gas begins to convert hydrogen into helium, and a star is born. This process lasts hundreds of millions of years. In the winter night sky, there is a very recognizable constellation, the constellation of Orion. It resembles a hunter holding a shield and weapon, with 3 stars crossed at its belt and 4 bright stars surrounding it, forming the main body below the belt of the constellation. Orion, you can see the cradle of the newborn stars, can be observed with the naked eye. Around these young stars, there are also dark and flat disks of gas called protoplanetary disks. Astronomers believe that these disks, under the influence of gravity, will form the first planets. As the stars get older, they consume more hydrogen. One day, the rate of nuclear fusion will slow down, causing the core to not be able to generate enough energy to counteract the force of gravity. The core will contract, the temperature will increase, and the fusion rate will increase. This is a cycle that main sequence stars have been going through. Our Sun has been in this phase since its formation. This is what the Sun looks like when it becomes a red giant. It looks incredibly scary. Try to imagine it from Saturn's perspective. Suppose the Earth's orbit remains unchanged, and it maintains its current distance from the Sun. The seawater at such high temperatures will start to boil, and our home will become a scorched earth with no life. The Sun that gives life to all will eventually become the one that ends all life. About 5 billion years from now, the fusion reactions in the core of the Sun will stop completely. Its core will contract rapidly, marking the departure from the main sequence in the He-Sprung-Russell diagram. When the outer shell of the red giant dissolves, the Sun will become a white dwarf with a mass of only about 54 pH. Its current mass. This means the orbits of the planets and asteroids in the solar system will gradually expand outwards due to the lack of energy to maintain the temperature of the white dwarf, which will stop nuclear reactions and gradually lose heat over time, becoming a black dwarf. At that time, the entire universe will only have dust and gas left, the black hole. And when celestial bodies move, the black hole will swallow most of the matter. The proportion of black holes in the universe will increase over time. The protons will decay, and all matter outside the black hole will be converted into light energy or elementary particles. At that time, the universe will only have black holes. However, due to the phenomenon of H.W. King radiation, the black holes will gradually evaporate, lose mass, emit light and heat, and eventually the entire black hole will disappear. At that time, the universe will only be nothingness. Energy and matter will be evenly distributed, and entropy will reach its maximum value. The universe will be in a state called heat death. But when you hear this, don't let it discourage you. Because the heat death theory is not the only reasonable hypothesis, and it itself has many incomplete points, although every star will go through. The process nuclear fusion is like wrinkles, also fade. Heroes also grow old. Talent will fade. Wealth will also disappear. But the efforts, the brilliant moments we have experienced, do not need eternity to prove their meaning to us. Now, this is the best time to be alive. We are living in the most beautiful stage of the universe there is.